Welcome Year 11s to this lesson. This is one of our final lessons on linear relations. In it, we're going to be looking at something called a piecewise linear graph. There's a picture of one to the right. What you'll notice is it is a linear graph, but it's a linear graph that's got different equations for different parts or segments of the graph. So imagine two or more different equations being plotted on a set of axes and they join. So you'll see that this first one here has a particular y-intercept and slope, and it actually ends at that point right there. Then what happens is we have a different relationship occurring for the x values from here onwards. And so we have a different steepness in this graph. That graph will have a different equation. It'll have a different y-intercept as well, but that graph is only plotted between this x value and this x value over here. This particular example has a third equation as well. So what I'm going to show you is how these ones will be written, so what they'll look like, and also how we would graph them. How do we go about graphing something that's got different equations for different parts of the graph? Now these are also called line segment graphs. So you might see that come up, or that language used instead of piecewise graph. But basically what we want to focus on is the plotting. So the joining of these graphs together by finding a finishing point, a starting point of the graph and a finishing point of each of these little segments. So that's what I'll try and focus on as I go through the couple of examples that I've got. Now we do have an ability to graph these on our calculator as well, so I'll show you that. And there are some instructions, or there's some screenshots in your notes which you can annotate as we go. So here's an example of a piecewise graph. We've got every Saturday morning Gary goes delivering newspapers. Now he is paid for delivering those newspapers. However, he's paid based on how many he is delivering. So he's paid 5 cents or $0.05 for each newspaper delivered up to and including 300. So if he just delivers up to 300, he's going to get 5 cents for each of them. After that, though, he's going to get 10 cents for every newspaper, so that if he is delivering, say, 301 newspapers, he'll get 5 cents for each of the 300, but then he'll get 10 cents for the very next paper. So hopefully that explains what that's referring to. What we can do, though, is we can plot this situation. We've got E for the earnings that he's making, so I'm going to put that on my y-axis. I'll just use the capital E, and this is of course measured in dollars, so I'll put that there as well. What we've got as well is N representing the number of newspapers, so that's just got that here. So if I go down a little bit, I'll put N representing number of newspapers on my horizontal axis. You'll notice you're instructed to do that here anyway. Okay, so what I'm looking at are two different relationships here. There's one relationship for n values between 0 and 30. So remember this notation here just means between 0 and 300. And this is simply meaning between 300 and 500. So we need an end point for the graph, and it's really telling us that we're going to plot it up to 500 newspapers. So I might just pop that onto this scale here. I might just go 1, 2, 3, 4, 500 there. And what you'll be able to see is because the change happens at an n value of 300, my first graph is going to be somewhere through here, and then my next graph is going to be probably on a very much so on a different angle, because you'll see it's got a different gradient. So it's going to have a different slope, but the change is actually happening here at n is 300. So what we want to do is first just focus on our first graph. Our first graph is 0.05n, and we want to start that at 0 and end that at 300. So since we've been using our calculator a lot so far, one way that you could get your the coordinates for this first graph, so where does it start and where does it end, is by plotting this relationship in your calculator. So 0.05n or of course, 0.05x. So I'm just going to do that here. I will show you shortly, though, how we can get both of them onto the same screen. But just for now, 0.05x looks like this. Now, I'm not too fussed about the window at this point because all I want to know is where does this graph start? So what's the value at x is 0? You can see that it's going through the origin, but if I use my graph trace option, you can see that it goes through 0, 0. So already I know, if I go back here, that this portion of the graph, and I might just write the coordinates on the side here, starts at 0, 0. And then where does it end? Well, it's going to end at an n value or an x value of 300. So I just need to know what is the y value there, or the e value in this case. So if I go back here and I type in 300, so an x value of 300, it tells me that that equates to an earnings of $15. So 300, 15 is where this graph is going to finish. So I've got my 0, 0 there already because that's the origin. I'm not going to plot this one just yet, just so that I get a bit of an idea of what scale I need, because I don't know where this graph is going to end. This second graph is going to end just yet. Okay, so if I go to this graph now, so I know where this one's going to start and finish. I'll plot that soon. I know this one here starts at 300. Now, I'm going to assume it starts at the same point, but we can check that in a moment. And then we want to know where it finishes. Where does this graph finish? Well, we know the x value has to be 500 where it finishes, but we need to know these two y values. So again, I'll just go back to my graph and I'll just undo this one because I don't want that one there actually. And I press tab so that I can put a new one in. So this new one was 0.10x. But then take away 15, because of course this graph is different. It's going to have a different y-intercept. So I'll press enter and I can see parts of my graph there. So again, I'll go menu, trace, graph trace. And I'm going to skip ahead to 300. And as you can see, it does start where the other graph ends, which is what we would expect to see with this sort of thing. These line segment graphs have got segments that join together. So this second part starts where the other one finishes. So at 315. But let's see where it ends. So I'll just type in now 500 and I can see it ends at 35. So that will give me this coordinate here, 535. Now that I know that this has to come up to 535, I can put a rough scale in. I might just go up in 5, so 5, 10, 15, 20, 25, 30, 35. I probably could have spread that out a little bit further, but that's all right. And my second one is at 535. This first one ended at 315, so I've got that on my axis as well. So then I just need to plot the two segments. So I'll just do that part and then the second part, adjust it. And as you can see, where we've got a certain slope, it's rising at a rate until 300, and then we can see he actually starts to get paid more per paper. So that's why our graph starts to get a bit more steep after that 315 mark. So do make sure you mark on your coordinates here. So this one here was 535, and our starting point over here was 0, 0. So you want to have all those key features, the endpoints of each of your graphs shown, and any coordinate where the graphs are changing as well. The last thing that I would recommend that you always do is label. So label these equations here. And so now we've got our two graphs labeled. We've got our axes labeled as well. So there's nothing else that I need to include on that graph. You might then be able to use it to answer some questions. So as you can see, we've got calculate the total amount Gary is going to earn for delivering 150 newspapers. So when you come across substitution questions like this, you want to just make sure you're using the correct equation. So you want to look at which part of the graph is this referring to. So an n value of 150 places me here. Have a look at which graph that actually lines up with. That's my E equals 0.05n. So importantly, it's this equation I actually need to substitute into, not the other one, because the other one was for greater than 300 papers. And so I'll multiply this by 150, and that means he will get $7.50. On the other hand, though, for 400 papers, that's up here. And if you have a look, that's beyond the 300 mark, so it's beyond where things changed, which means that I have to use this other equation to get the answer for this one. The other equation looked like this. So we substitute the value, the n value, into that rule, and we get for this one 25. So $25. So there's one example for you of how we can basically plot the graphs using the same skills we've already covered, and then the same thing, substitute into the rules. Not something that's new to us, but what is new is making sure that we identify which equation we're actually needing to use, and that will be clear from the intervals that you're given. Now, instead of doing each graph separately like I just did, I could have put it all together on one graph. Now, on the next page are screenshots for this. So I will show you very quickly, but what you're going to notice, it's pretty much exactly the same thing as I did just then, but you just get them on the same screen. You might find that's a benefit. Others might find it's just a bit more confused. It just leads to a bit more confusion that way. So our first step is to go into a graph, and then we're going to pick this little template. This template here is going to allow us to enter both the equations and the intervals that we're working with. Then all we have to do is adjust our window settings so that we can see the two graphs, which you'll see here. So what I'll do is very quickly show you that on this screen. If I open up a new graph, all I have to do to get those templates is if you press this little button that's next to the book. So it's underneath the delete button, just to the left of the book. When you click that, you'll see you'll get all these different options come up. This is our templates, and this is the one that you want. It's got a curly bracket, and then it's got 4 squares. Reason it's got 4 squares is it's going to allow me to put my equations in the first square. So I'll put them in first. And in the second square, it's going to allow me to put those intervals. So I'm just going to copy them as they are on my page, but what I'm going to do is use X instead of N. Now to get these symbols, you want to press Control and then your equals button in this corner, because then it will give you the less than, greater than symbols. Okay, so I wanted this one to be between 0 and 300. And the next one, you'll notice I use a less than symbol for this one here because the 300 actually belonged to that equation. It didn't belong to this equation. In other words, if he delivered exactly 300 papers, he was getting the 5 cents per paper. It was only after 300 that it changed. So this means it doesn't include the 300. Again, that was just given to us though, so I don't really need to worry about it. I just need to make sure I enter it in exactly as it came up. Okay, when I press enter, you'll notice I can't see all of the graph. It's only showing me a portion of it. So what I'll do is adjust my window settings. So menu, window settings. I'm going to change the X minimum to 0 and maximum to 500 because that's really what I wanted to see on my graph that I was producing. When I press enter, you see I still can't see enough of the graph. So I just press menu, window, and then the zoom fit. When you do that, it'll automatically adjust that y-axis for you. So here is my graph. I've got my first one with a particular slope of 0.05, then it gets steeper after that. So you see it's exactly what we just drew before, but we did it just a slightly different way. You can use your menu, your graph trace from here as well. So I can use this to move around the graph, just like I did earlier. Oops. And you'll see the different values pop up. So that's a second option for you. If you do need to, annotate this at all, you can, because you'll see it's not written out for you as clearly, but all the steps that you need really are shown in all of those screenshots. To finish off, just with one more, this last one I wanted to show you doesn't have any equations given to us. So sometimes this can be the case. However, if you're not given any equations, keep in mind that you might have enough information to get the coordinates, and that's really all we need. You've used the equations to get the coordinates to graph. I can get the coordinates instead and use those coordinates to get the equation because I've got my calculator to help me with that if need be. So first of all, we've got two people driving to a holiday house for a weekend. We've got Maya driving for the first hour, and we've got the speed that she travels, so 60 kilometers per hour. So she's only driving for 1 hour at 60 kilometers an hour, means that they must have traveled 60 kilometers at that point. They swapped though, and Joseph drives a bit faster. He drove the rest of the way and his average speed was 90 kilometres per hour. So they must have travelled another 90 kilometres in that second hour. So what you'll see here, it says total distance and total time taken. So in the first hour, they would have gone 60 kilometres. And in the second hour, they must have gone 90 kilometres since it was telling us their speed per hour. And so we know that altogether the distance they've travelled is 150 kilometres. In terms of the time, well, she drove for 1 hour and he drove for 1 hour. So we've got 2 hours altogether. Now, what we want to do is draw a graph to represent the journey. Now, we don't have any equations given to us, but it doesn't matter. We've got enough information. We're using D on the vertical axis and we're using time on the horizontal axis. Just label any units as well. I've got kilometers and I've got hours. Now, if we think about it, they're at the beginning, they haven't traveled anywhere. And so this graph is going to have to go through 0, 0. The other thing that we know is that they travel for 2 hours altogether, and that the change occurs after 1 hour. That's when they swapped seats. Okay, if you have a look up here, we've got one of our coordinates given because we know that after 2 hours, they have travelled 150 kilometres, which means that if I do maybe 50, 100, 150, I know that my second part of the graph is going to go through here. What we want to know is how far have they travelled after 1 hour? So after when they changed drivers, how far away from home were they? Now, Maya was the one that drove in the first hour and the speed was 60 kilometres per hour. So when they swapped, they were 60 kilometres from home. So that means at t is 1, we're going to have a distance value of 60. So I'll try and make that as accurate as I can. right, there we have it. Now we want to mark that on. And the other thing that we do, or we should always aim to do, is mark on the equations. So what are the equations? Well, I've got enough information, so I've got 2 coordinates for each equation to use my calculator to get them. So the first equation has got these 2 coordinates, and the second equation has these 2. So if I go into my listen spreadsheets and I put T first, T and D. My first one, 0, 0, and then 160. We go 4 for analyze, 6 for regression, and 2 for linear. So as you can see, we've got D equals, because it's not Y, D equals 60T. So it came out as that, which is D equals 60T. And then we just need to change this to have the other equation now. So 2, 150 instead of 0, 0. So I'll just change this one. 2, 150 and 160. Let's have a look. You can adjust this just so it fixes it for you. But as you can see, our other equation, negative 30 plus 90. So y equals negative 30 plus 90x, which using these letters is negative 30 plus 90t. So if you're wondering why have I got a y-intercept here of negative 30, it's because this graph here, it does start at 160, but if I was to actually extend it all the way down, I can't really do that with this. If I was to extend it all the way down, it's actually going to go all the way down there, which means that its y-intercept will be in the negatives. But because this graph doesn't go all the way to the y-intercept, it doesn't matter, but that is still its rule. All right, what was the average speed of the entire trip? So speed is distance over time. So their distance was 150 kilometres, their time was 2 hours, so their average speed was 75 kilometres per hour. Okay, I'll stop there because you will want to get some practice with these ones. They are a little bit more challenging, definitely, than your single graph that we've been looking at so far. So do make sure that you're asking for help if you need it when you start the exercise.